Problem number 41. We're provided with a piecewise defined function, and we're asked to determine which of these four statements is not true. Now be careful, not looking for what's true, we're looking for what is not true. Let's get started. Statement number 1, f has a limit at x equals 1. Well, let's see, our function is defined to be x cubed minus 1 over the quantity x minus 1 for everywhere except for when x is 1. So let's see what happens here if we can find this limit. As x approaches 1, x cubed minus 1 over x minus 1. Well, remember, we can factor because the numerator at the top has a difference of 2 cubes. So this is really going to be x plus 1. Nope, I lied. X minus 1 times the quantity x squared plus x plus 1 all over quantity x minus 1. And you see that the x minus 1 factors eliminate each other. So we've got the limit as x approaches 1 of x squared plus x plus 1. Well, direct substitution now works. This is going to be uh, 1 squared plus 1, which equals 3. The limit is 3, therefore the limit exists. Okay. Statement 2. F is continuous at x equals 1. Well, let's look at it. If x is not equal to 1, our function approaches y equals 3. If x equals 1, our function is 3 times x, 3 times 1, which is 3. Since these values agree, yes, our function's continuous. Now, to determine if our function is differentiable, what we'd have to do is kind of repeat this process, but with the derivative of the function f. So let us get started here. F prime of x is going to be a piecewise defined function. Oops. All right, so what we need to do is we need to find the derivative of x cubed minus 1 over the quantity x minus 1. Well, the good news for us is, as nasty as that looks like it might be, with factoring and canceling, we can really just find the derivative of x squared plus x plus 1, which is 2x plus 1. So this is our derivative everywhere except x equals 1. And now we need to find the derivative of 3x. Well, that's just 3. When x equals 1. Now let's see if these values are equal. F prime of x, f prime of 1, it's going to equal 3. And if we put 1 in place of the other piecewise defined part of this function, we get 2 times 1 plus 1, which is 3. So statement 3 is true. Let's see if statement 4 is true. It says the derivative of f prime is continuous at x equals 1. The derivative of f prime is continuous at x equals 1. So now it's a little sneaky. The derivative of f prime, that's really the second derivative. So let's find f prime prime, which is going to be a piecewise defined function. The derivative of 2x plus 1 is 2. The derivative of 3 is 0. Now these are not equal. Statement 4 is the false statement. So our answer is option A. Statement 4 is the only false one. Wow. Now that was a brain teaser. Hey, thanks for watching the video, guys. Hopefully it was helpful. Good luck on the rest of your work.